Hello everyone. Today's topic is AutoML, and under that, designing custom AutoML blocks in detail. So, what is AutoML like? AutoML is an automated machine learning aims to automate the end-to-end process of applied machine learning to real-world problems. This includes data pre-processing, feature engineering, model selection, hyperparameter tuning, and model evaluation. And the block is instead of viewing AutoML as a monolithic, a magical black box, or we can break it into a smaller, composable, and interchangeable units called blocks. So each block is responsible for a specific task in the machine learning pipeline. An analogy like, say, for example, you can take it as a Lego bricks. You can build the same thing with the same Lego bricks to make a car or a spaceship or uh, anything like the same way the custom AutoML blocks or or your custom or specific design Lego pieces. And why building custom blocks? Off-the-shelf AutoML solutions like Google Cloud, AutoML, H2O.ai, etc. are powerful but can be too generic, inflexible, and black boxes. What is too generic? Not optimized for your specific domain or data patterns. And inflexible means like difficult to incorporate unique business rules or proprietary algorithms. And black boxes are hard to debug or explain or trust for a critical. Next is designing custom blocks gives you like domain specialization, control and transparency, integration, innovation. Domain specialization like tailor the machine learning process to your specific needs, like example medical imaging, financial time series, or IoT sensor data, etc. And control and transparency, what is that? Like understand and control every part of your pipeline and integration seamlessly integrate with existing company infrastructure, data lakes, and deployment tools. And innovation experiment with novel search strategies, evaluation metrics, or architectural choices not available in standard packages. Next, the core components of an AutoML system. A typical AutoML system can be decomposed into the following code blocks. You can also customize any of these things. And those AutoML blocks or normal AutoML system blocks have a data loader and profiler, preprocessor, feature engineering, model selector, and hyperparameter optimizer, HPO, and evaluator and orchestrator. Right? So, what is data loader and profiler? It is used for ingest data and generates a summary report. Example: feature types, missing values or correlations, and examples of customization: custom data connectors. Example to proprietary database, domain-specific data quality checks. Preprocessor handles cleaning, imputation, encoding, and scaling. And examples of customization or custom imputation strategies. Example, using domain knowledge to fill missing values, novel encoding for cyclical features. Feature engineering creates new features from existing ones to improve model performance. Uh, Customization example, prime candidate for customization, domain-specific feature transformations, example calculating financial ratios, extracting technical indicators from time series, creating medical score aggregates. Model selector chooses a model algorithms from the candidate set, curating a custom model search space tailored to your problem. Example, only tree-based models for tabular data, only transformers for NLP, adding a proprietary model you developed in-house. And next is hyperparameter optimizer or an HPO. It is used for finds the optimal hyperparameters for the selected models. Examples of customization: implementing a custom search algorithm, example a modified Bayesian optimization, and defining a non-standard parameter space using multi-fidelity optimization like hyperparameter. Evaluators, its purposes or assesses model performance on a validation set. An example for the customization is defining a custom loss functions or evaluation metric that aligns with business goals. Example, a cost sensitive metric where false negative or 10x more expensive than false positives. An orchestrator, you can call it as a brain or denote it as a brain, manages the flow between blocks and the overall search strategy. An example for customization is implementing a custom search strategy that leverages prior knowledge from previous runs, meta learning, or designing a pipeline that can early stop poorly performing configuration. Next is design principles for custom blocks. When designing a block, we have to adhere to these principles. These four principles are modularity, interoperability, configurability, configurability, and reproducibility. What is modularity? Each block should have a single well-defined responsibilities, and a feature engineer block should also be tuning hyperparameters. Interoperability, like it itself explains, blocks must communicate using standard data structures, example NumPy arrays, pandas, data frames, um, PyTorch tensors. This allows you to mix your custom blocks with proper libraries like Scikit, Learn, Optuna, and Feature Engine. And configurability, a block's behavior should be controlled by a clear set of parameters. This allows the HPO block to optimize them. Reproducibility, the output of a block must be deterministic for a given input and configuration, or its randomness must be controllable via a seed. And this is a practical implementation guide. You can implement it. These thing. First, we have to creating a custom feature engineering block for financial time series data. And step one is define the interface. So your block should follow the familiar fit transform pattern from Scikit Learn to ensure interoperability. So we start from left to right. So you can use this sample code or you can write your own code. Next is step is implement a custom block. So you can use this sample code to create a custom block. So how you're customizing that particular AutoML blocks to perform, calculate simple moving average, calculate volatility, and calculate momentum, and add a custom feature, and one is for high, low percentage, and volume change, and that's it. Next is step three, which is in the implementation guide, like integrate the block into an auto ML pipeline. Now you have to use your custom block with a standard ML library, machine learning library. Here you can see the example using a scikit-learn and Optuna. So this will talk about define the objectives function for Optino to optimize it. And the second thing is suggest hyperparameters for our custom blocks. And the third thing you can see suggest hyperparameters for the model. And this one is create the pipeline with our custom blocks. That's the fourth one. And fifth one is train and evaluate. And once it is train and evaluate, you can do a create and run the study and print the best configuration. And that will move to the next, that is advanced concepts and best practices in uh, designing custom AutoML blocks. Those are hierarchical search spaces, meta learning, pipeline evaluation, and testing and validation, explainability. Hierarchical search spaces, some choices affect others. For example, if the model selector chooses a linear model, you shouldn't tune tree-specific parameters. Libraries like Aptuna support conditional search spaces. Meta-learning use results from previous AutoML runs on similar datasets to warm, start, or guide the search process on a new dataset. Example by suggesting promising model types or hyperparameter ranges. Pipeline evaluation, instead of just tuning parameters, evolve the pipeline structure itself. Example whether to do PCA before or after feature engineering. This is known as the combined algorithm selection and hyperparameter optimization, which is also called as cache. Check out Depop for inspirations. Next is test and validation. Rigorous test each blocks in isolation and use synthetic data to ensure it behaves as expected. For the overall system, use a hold out test. I said that the AutoML process never sees during its search or get an unbiased performance estimate. Explainability, like incorporate blocks that generate explanations, example, shape, SHAP and line, for the best found model to build trust at test time. Next is tools and libraries to leverage. You can use the core ML, scikit-learn for pipelines, models, and pre-processing. Hyperparameter optimization, Optino highly recommended. Scikit optimize, uh, hyperopt. And next is feature engineering in that feature engine or category encoders can be used. And full featured AutoML frameworks for these you can use Teapot, evolutionary algorithm, and Auto SK Meta Learning, and H2O.ai enterprise grade. And conclusion about the designing custom AutoML blocks or shifts you from being a user of AutoML to a creator. It allows you to embed your domain expertise directly into the automation process, leading to a more effective, efficient, and trustworthy machine learning solutions. And start small by customizing one block, like the feature engineer, and gradually build out a more complex and powerful system. So this will be an insight into how you build a design custom AutoML blocks. Thank you all.